Hi everyone, I am Ankit Misra and I have been guiding GATE chemical engineering aspirants for last 5 years. I am excited to bring you a comprehensive PYQ previous year question series covering all the subjects designed to strengthen your conceptual understanding. So each video is organized topic wise, allowing you to focus on weak areas and master them efficiently. So don't miss out, subscribe my channel and share it with your friends to maximize your preparation. So without wasting our time, here is the third PYQ lecture of fluid mechanics, and the topic is fluid kinematics. So in fluid kinematics, generally we'll be talking about when the fluid is in motion. So till now we have understood about the fluid dynamics topic where fluid was in a static condition. So the first question says a steady flow field of an incompressible fluid is given. So the velocity vector v vector is given to you, ax plus by I cap minus ay j cap. Okay. So you can see there is a velocity component in x, y and I and j direction. Two-dimensional velocity profile is there, means 2D flow is happening, and value of a is equals to 1 and b is also 1. So velocity vector can be written as x plus y I minus y z. So if I am talking about this one is u vector and this one is a small v vector, so velocity component in x direction is u and y direction is v. So from here you can write u is equals to x plus y, v vector is equals to y minus y. Is that clear? So you are supposed to write the acceleration. So first I'll write acceleration a1 vector. So a1 can be written as u del u by del x plus v del u by del y. So what is u? U is your x plus y, and del u by del x is 1, plus what is b? Minus y, and what is del u by del y? That is 1. So you can write x plus y minus y. It will get cancelled out, so that is equals to x. So a1 vector will be equals to x, and the value you are supposed to calculate at point 1 and 2. So let's say you have calculated a1 vector. Now a2 vector, that acceleration along the y direction, you can write u del v by del x plus v del v by del y. This is the convective acceleration. So you know x plus y, and del v by del x is 0, plus v is minus y, and del v by del y is minus 1. So that is equals to y. So if I want to write in terms of magnitude, so a1 vector will be equals to how much? You are supposed to calculate at point 1, and a2 vector will be equals to 2. So what is magnitude of a vector? That will be equals to root over a1 square plus a2 square, that is equals to 1 plus 4, which is equals to 5 root. So the acceleration vector you have got the value 5, root over 5, right? So just check the answer, which of the following options are correct. So option C will be your correct answer, right? So here you have to understand which is your x direction of velocity and y direction of velocity, and how can you write the acceleration along x and y direction. So moving towards the next question. The next question says that for an incompressible fluid, the x and y component of the velocity is given. So again, x, y component of velocity is given. I am not going to write all of these data because I am just trying to let you understand how to solve in actual GATE paper. So you don't have to write all of these things on the scribble pad. Then the z component of the velocity vector of the flow for the boundary condition vz is equals to 0 at z is equals to 0. So boundary condition is also given to you. So when we talk about all of these things, we have to apply the continuity equation. So what continuity equation says that del u by del x plus del v by del y plus del w by del z equals to 0, means del dot v vector, that is equals to 0. Is that clear? Divergence of velocity vector will be equals to 0. Now u vector is given, that is u is vx and v is vy is your this one. So del u by del x will be equals to 2 plus and del v by del y will be equals to 3 plus del w by del z will be equals to 0. So del w by del z will be equals to minus 5. So w will be equals to minus 5z plus c. Is that clear? So you have been given that at z equals to 0 velocity, that means w will be equals to 0. So 0 equals to 0 plus c, so the value of c will be equals to 0. So what is the z component of velocity? W, that is equals to vz, which is equals to minus 5z. Okay, so this will be your answer. So from here you can match your options. Your option B will be your correct answer, right? This is very simple question based on the continuity equation. So the concept that is being used in this problem is continuity equation, and this is the vector form of continuity equation. Okay, so what is del? Del equals to del by del x I cap plus del by del y j cap plus del by del z k cap, and obviously v vector can be written as in this format vxi plus vyj plus vz k. So when you do the del dot v vector, it should be 0 when I am writing the continuity equation, something like that. Okay, then we'll move towards the next question, and the next question says that the stream function is given to you here, right? So so psi is given to you, the velocity vector of this stream function. So you are supposed to calculate the value of velocity in x direction and y direction. So when I am talking about the velocity vector, so velocity vector can be written as vxi plus vy z vector, right? And if I want to write in terms of a stream function, it can be written as del psi by del y I cap minus del psi by del x j cap. Okay, so okay, so what is vx here? The value of vx will be equals to what? Del psi by del y, and what is by? That is equals to minus del psi by del x. So just try to calculate these things, that psi is given to you, psi function, that is a stream function, is half and x square y cube, right? So what is vx? Vx is equals to 1 by 2 del by del y of x square y cube. So that can be written as 3 by 2 x square y square. Now what is by? By equals to minus 1 by 2 del by del x of x square y cube. So once you will do the differentiation, you will be getting minus xy square, sorry, xy cube. So you have calculated the value of both velocity vector and these things, acceleration vector, sorry, component of velocity along x and y direction. So v vector can be written as now vxi plus vyj. So v vector will be equals to, now what, vx is 3 by 2 x square y square I cap minus xy cube j cap. So from here you can match your option, which of the following options are correct, and you will be getting the answer. Is that clear? So you can say that 3 by 2 x square yi minus xy cube j. So option B will be your correct answer. Is that clear? Okay, moving towards the next question of today's discussion. This is a really good question. An incompressible fluid is flowing through a contraction section of length L and has a one directional x direction steady state velocity. So velocity is given to you in this problem u naught into 1 plus 2x divided by L, and where u naught value is also given to you, that is constant meter per second, and the value of L is 3 meter. The convective acceleration of the fluid is, so when we talk about the convective acceleration, a vector, so that can be written as u del u by del x, because here one dimensional velocity profile is given, that's why you will get acceleration along that direction only. V is not given to you, so that is 0. So you know what is del u by del x from this particular formula, so that will be equal to u naught into 2 divided by L. So what is a vector? A vector will be equal to u naught into 1 plus 2x by L multiplied with u naught into 2 by L, and you are supposed to calculate when x equals to L is, right? So what is a vector? A vector is u naught is given to you, how much? That is 2 multiplied with 1 plus 2 into L divided by L multiplied with u naught is 2 into 2 divided by L is your 3. So L will get cancelled out, so that will be equals to 2 multiplied with 3 multiplied with 2 into 2 divided by 3. So it will get cancelled out, and 8. The acceleration vector, convective acceleration you are getting here is 8. Is that clear? So 8 meter per second square. So from here you can say that will be 8 meter per second square. Is that clear? Okay, great. So after that I'll be moving towards the next problem. The next question says that in a steady incompressible fluid, the velocity distribution is given. So the value of velocity vector is given, that is 3xi cap minus py j cap plus 5z k cap. So this one is u vector, this one is small v vector, and this one can be w vector. So this is three-dimensional velocity profile, and in order to satisfy the mass conservation equation, the value of constant. So when we talk about the mass conservation equation, means continuity equation should be valid for that. So for continuity equation, I have already discussed in the first problem that del dot b vector should be equals to 0. Means del u by del x plus del v by del y plus del w divided by del z should be equals to 0. So from here you can say that what is del u by del x, that is 3, minus del v by del y is p, plus del w by del z is 5, that should be equals to 0. So the value of p will be equals to 8. Is that clear? So from here you can say that value of p will be equals to second inverse, right? Okay, this is very simple question that was based on continuity equation. Now moving towards the next question. This question has been asked in GATE 2021. So the question says that a three-dimensional velocity profile is given to you, that is v vector, which is equals to 5x square y plus cyj minus 10 xyz k, right? And after that, describing Cartesian coordinate system, the coefficient c of the constant. So again this question is similar to the previous question. Again you are supposed to calculate the constant c. So you have to understand that del dot v vector will be equals to 0 for to satisfy the continuity equation. So I can write del u by del x plus again del v by del y plus del w by del z should be equals to 0, and u is 5x square y. So del u by del y x is 5xy plus del v by del y is c, and minus del w by del z is equals to minus 10 xy, that is equals to 0. Is that clear? So if you'll see here, it will get cancelled out. So finally you will be getting value of c will be 0. If c is 0, then y component of the velocity is going to get 0. So means this flow is happening in only two direction, I and k direction, right? So value of c component is 0. Is that clear? Okay, so this ends the discussion of the fluid kinematics questions. So 6 questions were asked till now in fluid kinematics. So you can see that out of 20 years, 6 years they have asked questions. So again this topic is becoming very important, but you can see 1 marks question is coming from this particular topic, and the question is very simple. So definitely you are going to get 1 marks from here. So it may be possible 2 marks question can come, but yeah, this is a really important topic, and this is very fundamental topic. Okay, thank you, and see you in the next lecture where I'll be talking about the fluid dynamics, right? That is very important topic. Every year 2 marks question is coming from fluid dynamics. This is a really important topic of fluid mechanics. Okay, thank you, see you in the next lecture.